So in this video we will discuss about the graph of blood pressure. As you guys all know, what is blood pressure? The flow of blood. So the flow of blood and the pressure of the blood is called the blood pressure. Okay, so today we'll be discussing about the graph. In the previous video we will discuss about the blood pressure in very detail. So through the graph you can easily understand. First point of the blood pressure, I told you guys before that in aorta, when the ventricle contract in aorta, the blood pressure will be high. Blood pressure high. If we talk about the capillaries, so that will be having less. Why? As you guys all know, I have given you the example of the pipe, that if the pipe is there, if I'm like holding the pipe this, so here at my thumb, so there the pressure will be more as compared to the you can say the far of the pipe. So that's all the things, that aorta is like you can say that very closest to the ventricle, so there the pressure is more, and capillaries are very far, so that's why the pressure is less in the capillaries. So through the chart you can easily understand that what I am talking about. Okay, okay. So this is basically the pressure of aorta, artery, sorry, this is the pressure of aorta, artery, arteriole, this is of the capillary, again this is the pressure of venule, this is veins, and this is vena cava. So this will tell you about the velocity, okay, the speed of the blood, 30, 40, 50. So this is basically this is the force that is applied by the heart, force of heart through which the blood will flow. And this will tell you, this is basically the cross sectional area, this is the cross sectional area, which will basically cross sectional area. Okay, so this is cross sectional area of the blood vessel. Okay, so yeah, one thing I want to tell you guys, here you can see this is the cross sectional area. Here you can see that the blood pressure in aorta is more, then in artery it is decreasing, then in arteriole it is more decreasing. If we talk about arteriole, it is more decreasing. In capillary it's like too much decrease. Here you can see the too much decrease. There the pressure was 50, for example, now the pressure is 0. After that the pressure is increasing, and after that there the increasement of in the vena cava. So this is the cross sectional area, which is basically the inversely proportional of the force. That, for example, the force of a heart is more, the force of a heart is more, so here you can see the cross sectional area is less. Here you can see the cross sectional force of a heart is coming like you can say that very less. Here less. Here the cross sectional force of the heart is very less. Here you can see the cross sectional area is increased. Here increase, which means that the increasement of the, you can say that the cross sectional area is basically inversely proportional to the force. That if the force is decreasing, the cross sectional area is increasing. So we can say that the force basically applied, that is basically systolic. Systolic, because as you guys all know, the ventricle contract. Okay, the ventricle contract, pressure will generate. So the force applied of heart is basically by the systolic, you can see the ventricular. And the at capillaries, if you talk about, that is diastolic. As you guys all know, at diastolic, ventricular, the basically the ventricles are relaxed, so there is no pressure. So that's where the capillaries is having the diastolic. So if we talk about the highest cross sectional area, cross sectional area cross sectional area, which here it is less, it is greater at the capillary. Cross sectional, highest cross sectional is at the capillaries. Why? Because there is very less pressure. If we talk about the less, so less is at the aorta, so we can write it less cross sectional at aorta, not aorta, yes, aorta, sorry, aorta. So after veins, you can say that the through after capillaries we are having, you can say that the venule, not venule, yeah, venules, then vein, and then vena cava. So your mind will say that at vena cava there is like no pressure is there in veins. But how the pressure is more in the vena cava? That is just because of the surrounding muscles. There are the surrounding muscles around the vena cava. So through that they are getting the pressure. So through the surrounding muscles, they are getting the pressure. So the cross sectional area is basically highest in the capillaries, which means that the force is less. Force is less. Force less. Okay. Force less, which means blood pressure is less. Blood pressure is less, which means there is the highest cross sectional area. Here you can see that the force is decreasing, the cross sectional area is increasing. Here you can see the measurement, you can see that the aorta is having more pressure. As compared to aorta, the artery is having less. As compared to artery, the arterioles is having less. Capillaries, you can see that they are too much, like very little space, very small space. So just because the pressure is low at the capillary. If we talk about the aorta is having highest blood pressure. If we talk about capillaries, they are having very less blood pressure. And again, the pressure is basically increased in the through veins to the vena cava. So the capillary is having the less pressure. So this was about the graph of the blood pressure, which means that the aorta is having high blood pressure and capillary is having the less blood pressure. So this was about the, if you talk about why, you are saying, your question will be arise why the aorta is basically, you can say, having more blood pressure. Just because this is nearest to the heart, this is nearest to the heart and this is very far to the heart, so that's why the pressure is basically less at the capillary and highest in the aorta. So this was about the graph of blood pressure.